just a quick warning that what you're about to look at has variables that may be different than what you've experienced in an assessment, such as an exam or homework. It might look really similar, but it might not be the same. Hello everyone, this is Michael Ratajczak here to show you a little bit of forecasting. So we've got a data set here. We're looking at some chocolate cake here. We've got orders placed by month going from January 2018 to October 2019. So these are the orders placed for chocolate cake. We're going to do a multilinear regression. We're going to do an exponential smoothing with a damping factor of 0.2. And we're going to do a 3-month moving average forecast. Because I'm asking for the absolute forecast error, I've got AFE, MLR, AFEES, AFEMK. Now, those of you that know how to do this, you know that linear regression is the only one where these variables are useful. The rest of it is based on previous values, so we will only use this when we do regression. Okay, now one thing that I ask you to look at first to be really good at this is create a chart, folks. Create a chart. So we're going to insert column chart or line chart, whatever it is, whatever, it doesn't matter. Usually we think of line charts. So let's look at this little line chart here. Wow, look at that. We got a big peak. We call these peaks, and then valleys. Peak, valley, peak, valley. So this whole thing's a valley, peaks and valleys, just like Winona, where we've got the bluffs, then we've got the river, and then we got bluffs again over in Wisconsin. Beautiful. Okay, so you have to ask yourself as an analyst, why are there peaks? Well, the answer to this is, what month is this happening in? February and February. So, chocolate cake sold at a fancy restaurant in February? What could that be all about? Guess what, folks? Valentine's Day. So, all these people are going out, they're dressing up real nice, they're going on Valentine's Day dates, nice fancy dates. And what are they doing? They're getting that romantic action going on. They're getting chocolate cake with berries and whipped cream, all that good stuff. So we have seasonality in our data set. So that's very important for us to think about. Now, I'm going to go through the mechanics today of just doing plain vanilla forecasting. But you would really want to look at another video that I've produced on seasonality to identify, are there seasons in this data set? I would argue there are. It's a month, February. Those are peaks. So again, a great step at looking at your data. Okay, we'll just move that over to the side. Let's delete that whole thing there. So let's go ahead here and do regression. Okay, so here's what we got. We got data analysis. I'm going to go right down to regression, and we're going to fill in these boxes. Now, because I did this before, it's already filled it in for me, but let's just wipe this out and go from scratch. Excuse me. The y variable is our dependent variable, what we're trying to predict. We're going to grab all of the orders, including the label. So we'll checkmark label. All of our x values are going to be these things. So we'll grab those labels. We're going to grab all that stuff. Output range. We can do this in a new workbook, new worksheet, whatever. But I like to put the data over here so that I can see it after it's produced and then use it immediately. All this stuff over here for a later video on residuals, errors, and plotting those errors, things like that. We've got some data. R squared is 0.67, not too bad. Our statistic is below 5%, great. What are these p-values at? Oh, these p-values are kind of bad. Ooh, bad p-values. We'll see how this plays out in the model. Okay, so next thing. We look at the coefficients. Intercept is 5. Gross domestic product is -4. Personal consumption expenditures, 1.6. So, and what you're looking at here is number of cakes. Okay, so this intercept basically says if all of these variables are 0, then we're going to sell 5 cakes. But for every percentage of growth or change in GDP, we're going to lose 4 cakes if it's a positive number. Okay, durable goods, if that, and so forth, just 11 cakes. If there are articles on diabetes and sugar in the marketplace, we will sell 11 more cakes. Okay, we will sell 11 more cakes every time there's a new article warning us about diabetes and sugar. Okay, kids hit by ponies in Waukesha County. Okay, so if kids are hit by ponies, we're going to sell 59 more cakes. Well, does that make sense to you? Do these last few variables, and here's one. Baby is born 9 months prior last year. Basically, the idea here is you go out on a Valentine's date, you get pregnant, perhaps, and you have a baby 9 months later. So if that is true, then we sell 14 more cakes. Now, you got to think about this. I'm going to show you the mechanics here, and I promised you that, but some of these variables are just goofy, right? Like, what does kids being hit by ponies have to do with selling chocolate cake? Like, maybe you could go crazy about this and say, well, every time there's a kid that's hit by a pony, we buy them a chocolate cake at this fancy restaurant. 60 times, like 60 cakes per kid? That's insane. Articles about diabetes and sugar. That should have the opposite effect. That should be a negative coefficient, okay? That should be like saying, well, every time we find out sugar is bad for us, what do? Oh, we go buy a chocolate cake. No, we wouldn't do that. So that is why when you look at the p-values, they're total trash, right? You want less than 5%. So what this is saying is we've got bad sampling. We've got coefficients that don't make sense. Okay, fine. Just gave you a bonus round before we actually did what was guaranteed in this video. Okay, so now let's go ahead and input our data. Now this is going to be a long, tedious process. Y equals just 2.6 or 2.7 times the gross domestic product plus this times this 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 plus our intercept. That's a lot of stuff there. Don't mess it up. Convert this to actual numbers. Now I like to go over to all of my references in U and freeze them because we're about to use them when we drag down on our sheet, and I would hate to lose our references. Okay, and let's do that. Drag down. There we go. Okay, so exponential smoothing forecast. Can't do the first one, NA. You do the second one, but we got to do that first. Again, this is all in percentages. You got to clean that up. Next. Old orders times the damping factor of 0.2. Where'd you get that from? I gave that to you. Plus the previous forecast times 0.8. So we're relying on our forecast more than we are on our actual orders. So some companies might do like a 60-40 or an 80-20, whatever. But in this case, we're doing this. Okay, drag down. Okay, good. Now we're doing a 3K moving average. We cannot do one for this, cannot do it for this, cannot do it for this. So now we can start it. And always make sure that you're going over to the averages or orders section. Do not go to your previous forecast and mess this up. Okay, excuse me. Okay, now we got our forecast. Now it's time for the absolute forecast error. Now we use the ABS function, which is absolute value of forecast minus or orders minus the forecast. Okay. And drag that down. And we do this. Again, orders minus the forecast. Make sure you line it up with the correct one. Yes, that's going to produce an error. That's fine. Again, one thing I messed up there, absolute cell reference or absolute value. Make sure you get that in there. Okay. And finally, ABS of the orders minus forecast. Give us some errors in there. Okay. So now we have all our stuff. Make it pretty again, button it back up. Now we can take the averages, right? So what is the average forecast error for all of this? Now be careful, we just did that. Don't just copy over because we're going to be picking up these value errors. So, and then don't just copy this over because then you're picking up the value errors again, but you got to keep fixing this and get the references, okay? So, what is the answer to this? Which one has the least amount of forecast error? This one does. Multilinear regression has the least amount of forecast error. Now, you might be saying to yourself, sweet, I solved the problem, great. However, a best-in-class analyst has to look at the data and say, does that make sense? Have we gone far enough? No, because as we just talked about, a lot of this is wonky. The p-values are horrible. So I don't care that the R-squared looks good. I don't care that your F-statistic looks good. The p-values are trash. This stuff doesn't make sense. So even though this is the best method, according to this data, it doesn't mean it is the right tool to use. I mean, look at this. We were off by 100 units in March. Okay? Look at that. 100 units. Let's just do a color scale on this. How far off we were. Okay? Like we just did an average, right? That's fine. But look at our color scales when we do this. Okay, dark red is bad. Okay. Do dark red is bad. There we go. Okay, so we were off by 100 units, off by 80 units, off by 75. What we should really be doing is standard deviation. What is the standard, ST-dev of these numbers? How far off are we? And now again, you have to redo the references. Okay. How far off are we? Well, this one again, so we're not that far off. Okay. Now, another thing I like to do is coefficient of variation, which is ST-dev over mean. So ST-dev over mean. So we have a lot of variation in these other ones, which goes without saying over here. So this one, yes, it's showing it's the best one, but I would expect out of a best-in-class analyst, a student that's taking our classes, to challenge that. Like, how do you, that's still wrong, right? I mean, wow, you just ordered 100 extra cakes because you had a forecast that said you were going to sell 119 cakes, right? That's bad business. Here. What I would challenge you on is, are these the right variables? Can I go find other variables that would make this a better forecast? Heck, what you could do, you could actually delete these 3 variables and just run the model again without these 3 variables, because maybe these 3 variables are the ones that are really hurting your model. Maybe, right? I mean, look at this. This is horrible. I hope you see this. There is only one time period where a kid was hit by a pony. This is bad data, folks. Great example of bad data. Okay, so thanks for watching. See you later. Hey everybody, I want to do a bonus round. Okay, so remember how you had to do this on your exam? Okay, I did some conditional formatting there, did that stuff. Now I'm starting fresh here. Now you might think, how did I get that there so fast? Well, if you do everything carefully, go back to regression, it remembers what you just did. So you didn't have to change a damn thing here, pardon my French. It'll still spill out into T2 just like it did over on the chocolate cake, right? And boom, boom. So each time you go to Solver or data analysis pack, it should show up in the exact same spot and do all the work for you. So why struggle? Why reinvent the wheel? Be smart. Okay. So now you can look, wow, 0.56. F statistic is okay. P-values are a little bit better, a couple of them, but they're still kind of nasty. Let's look over here. R-squared 0.7, good F statistic. P-values, they're a little bit better, not too bad. We got 3 of them below 5%. They're not astronomical anymore. Okay. So here's a cool trick. So go back to your chocolate cake, and you know where you did your formula up here? Copy your formula. Just copy it up in the ribbon. paste it down here. Change the formula or format. Double click to make sure you got the references right. Boom, beautiful. Boom, 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 boom. This works because we have the same number of variables. Beautiful. We don't have to redo all that stuff. Wonderful. In fact, you could do the same thing over here, folks. Just grab this stuff. Grab it all. Boom. Got it all there. Just double check. Perfect. Lovely. Hey, guess what? You can do the same over here. Grab all this stuff. Boom. Boom, boom, boom. Done. Beautiful. We just did the whole thing. Oh, I lied. Got to do the bottom. Boom, 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 boom. Grab the 35. Done. Boom. Okay. Here's a hint. You could actually grab the whole thing. Grab all of this. Go over to here. Boom. Done. You just did the whole thing. Done. Double check your references. Done. Beautiful. Awesome. You just did it. Now go to Blackboard and answer your questions. Done.